biết mát rồi.
మల్టిపుల్ వస్తుంది. ఇది ఇట్లా రావాలి కదా.
ఇది చేసి నుంచి వస్తుంది సార్ అక్కడ షేరింగ్ స్టాప్ షేరింగ్ అనేది ఒక స్టాప్ షేరింగ్
Uh, Good afternoon. Good afternoon, all of you. Today I'm going to discuss about the logic families. So in this logic families, we are going to study about the IC how the IC is built, and then their different technologies used for different families. We will understand. So first of all, this digital logic gates. We know everyone familiar that AND gate, OR gate, and NAND gate, NOR gate, and exclusive OR gate. Suppose if you look at the AND gate, the any one input is one and one is one, output is one. So this being the AND gate, and you will get the output only both inputs are high. Then you will get output as high. So, in a similar way, this or this, A or B is 1, then output will be 1. So, this OR gate, this or this, A or B is 1, output is 1. So, and then this OR gate is built in this accordingly. Whereas for AND gate, if it is a negation is added, then you will get the output is negated. So, you will get the output. So similarly, for OR gate, output is negated, then we'll get an OR gate, and the exclusive OR gate, either of the input is one only, then you will get the output. So this is how the basic gates that works. So this gate can be built using either the TTL logic or MOSFETs or different families that we can see. So looking at the families, logic families, basically there are two types, unipolar and bipolar. The in unipolar, this is a MOS technology, metal oxide semiconductor technology, which is P-type metal oxide semiconductor, and NMOS is an N-type metal oxide semiconductor, and this is a complementary metal oxide semiconductor. These are the three different types which is works under the field effect transistor, which is the potential is the voltage is the main part in understanding these type of devices. Whereas there is a voltage control device. These are the unipolar devices are voltage control device, whereas the bipolar is a uh, current control device. So in this again, saturated bipolar and non-saturated bipolar circuits are there. In the saturated, if you look at transistor transistor logic, resistor transistor logic, diode transistor logic, there are three types are there. Similarly, their non-saturated types are ECL and Schottky TTL. So TTL is a transistor transistor logic, which is a version, whereas uh, this particular ECL logic, emitter coupled logic, and Schottky logics are more versatile used in making the ICs. So coming to this, logic families can be classified broadly. So this just now we have discussed this within each family, and then nomenclature of the family. Now just now I explained this. This suffix used for packaging, plastic dual in line package, and ceramic flat package. And if D is on IC, if it is mentioned D, then surface mounted plastic package. Then if it is a suffix used for subfamily, H indicates the high speed, and L indicates low power, S indicates Schottky diode, so, and AL indicates advanced low power Schottky. So these are the different technologies used in making the ICs. And again, there are company names also mentioned before the IC number. That S is, stands for Signetics, and SN stands for Texas Instruments, DM for National Chemicals. Like this, there are so many other companies are also manufacture these ICs. Then coming to the diode logic family, logic family, the logic implemented using the diode. So this is the diode, using the diodes only it will be designed. So diode logic suffers from voltage degradation from one stage to the next stage. Diode logic only permits OR and NAND gates. The other gates that we cannot uh, construct using this particular logic. So diode logic is used extensively but not integrated circuit. Now coming to the RTL family, that is resistance transfer logic. This logic is are implemented using the resistors and transistors. Here, this is the input connected to a resistor R1 and connected to the base of the transistor Q1, and the other input is connected to another transistor of the base, and these two connected in this, and output is taken across the two collectors, which is X plus Y. Uh, NOR gate is designed using this particular logic. So the transistor is basically used for both two applications. One is amplifier. You can use transistor as an amplifier, and also transistor used as a saturation on-off switch. So when the transistor is operated in the active region, and it can be used as a amplifier. Suppose if you want to use transistor as a switch, if it is used in the active region and saturation region, if it is used, then it will be acts as a switch. So now the minimum base voltage is not sufficient, then the transistor will be switched off. If the sufficient voltage is there, for example, a logic 1, so that the that is logic 1 is around 5 volts is the input voltage. For this, the transistor will be on, then the output will be 0. So similarly, if the logic the Y input is high, that is 1, that is plus 5 volts, then the transistor will be on state, and the output that you get is 0. So 1 1 you will get output as 0. So any one input is high, so automatically the output goes to 0. So this is how the RTL logic works here, resistance and diode. So this will be operating in the saturation and active and the cutoff region. So in the cutoff region it will be off, and in saturation it will be on. So this is all about the RTL circuit, and this symbol is for NOR gate. Then coming to the transistor logic family, one basic function of TTL IC is complemented switch. This is again in the transistor as a switch we are using this. Here the minimum base voltage is sufficient to switch on the transistor. What is the minimum base voltage is? At least 0.06 is the minimum base voltage between base and collector. Then the transistor will be on. Once this is on, the output goes to 0. How? VCC minus ICRC is the output voltage. VCC minus ICRC is the output voltage. So VCC is there plus VCC and minus ICRC. So VCC minus ICRC value will be equal to this, because when it is on, then VCC minus ICRC value both will be equal, so that the output will be 0. So this is how when the input is high, then output will go low. That is what the an inverter works here. So when V in equals to 1, the transistor is turned on, and V out equals to 0. When V in is 0, the transistor is turned off, and V out equals to plus 5 volts. That is RL is greater than RC. So that is the condition that the resistance value that we choose in designing. Thus, level 1 of the inverter output is much dependent on RL. So this is all about the designing aspects of the RTL logic. When the transistor is saturated, this is what I discussed just now. Thus, we need large RC when transistor is in saturation, and small RC when transistor is off. Then again, TTL logic, the idea of RC is accommodated by TTL IC. It uses another transistor Q3 transistor is also used here in place of RC to act like a very resistance. So Q3 is cut off when the output transistor Q4 is saturated and Q3. is saturated. When output transistor Q4 is cut off, thus one transistor is on and at one time. The combination of Q3 and Q4 is called totem pole arrangement. These two transistors which is connected in the totem pole arrangement. Q1 is called the input transistor, which is multi emitter resistance, and that drives the Q2 transistor, which is used to control Q3 and Q4. Diode D1, D2 is used to protect Q1 transistor, unwanted negative voltages, D3, and ensures Q4 is on and Q3 is off. So this is how the an IC looks like. So this is the Signetics company is manufactured ST. So manufactured at Malaysia, and this is the number is HCF 4016 BE is the IC number 4016. So this is a dual in package. So the common pinout like diagram is this. Then the other pinout diagrams of inverter and AND gate and NOR gate. These are the pinout diagrams of this. They are designed in dual in package. In each IC, this number of inverters are 6, and in this IC, the number of AND gates are 4, and number of NOR gates are also 4 here. So whenever it is required, we can use 4 or 3 or 1. So maximum is 4 that we can use from this. This is another circuit using the TTL logic. So this is an AND gate constructed using this. So when one or both inputs are low, the base emitter junction Q1 is forward biased and Q1 is on. And the output at collector will go low, making Q2 off. So whenever this is on, the output goes low, so that this will be, once it is on, then output goes low. Then Q4 off and Q3, Q4 off and Q3 and D1. On making output high, the power dissipation in R1, Q1, R2, R4, Q3 and D1. When inputs are high, base emitter junction of Q1 is reverse biased and Q1 is off, and output at collector will be high, making Q2 on, and Q4 is on and Q3 and D1 is off, so output goes low. So the NAND gate as the 0 0 are the inputs, then output goes high because it's like a inverter, it is connecting, and 0 1 output is also 1, and one any input is 0, then output goes 1. Then both inputs are high, then output will be 0. So if both inputs are zeros, then the output, because it is switched on during the both inputs are on, then output will be 0. So this is how the output of the NAND gate works in this. Now the other performance parameters of the logic families, we have to consider the fan out, input and output voltage level, noise margin, and rise and fall time, and propagation delay and power dissipation. So these are the main important characteristics of any IC that we manufacture. So we have to look into this. So we'll see one by one. So fan in and fan out. What is the fan in? Is a fan in or a gate is number of inputs that can practically be supported without degrading practically input voltage level. It means one IC can have any one gate can have any number of inputs. So that how many number of input that each one can handle, one IC can handle, that is the fan in component of this. Similarly, the output, the maximum number of digital input that the output of a single logic gate can feed, and gate must be the same logic family, is calculated from the amount of current available in the output of a gate and the amount of current needed in each input of the connecting gate. It is specified by manufacturer and is provided in the data sheet. So exceeding the specified maximum load may cause a malfunction because the circuit will not be able to supply the demand power. Then this is another diagram for this. The number of output current, the fan out of a subfamily is defined as the number of gate inputs of the same subfamily that can be connected to a single output without exceeding the current ratings of the gate. A typical fan out or most TTL subfamilies is 10. Uh, so the fan out is really depends on the amount of electric current a gate can source or sink while driving the other gates. So the minimum number of gates that can handle the other output side or the input side, we have to be very cautious. The maximum number is 10. So while designing any IC in the circuit, we have to look into these parameters and we can design the ICs. This is another point in this. Then coming to the input and output voltages. Now the output voltage for high, which is not 5 volts, it is from 2.4 voltage onwards. We consider the logic as 1, and the minimum value of the output is a logic 0. It is not 0 volts, it is at least for 0.4 volts is the minimum voltage that we can have. So the maximum voltage for logic 1 is 2 volts, and the minimum voltage is maximum minimum voltage will be 0.8 volts as a TTL. Then coming to the noise, this is the low noise margin. So VI low maximum 0.8 minus 0.4, which gives you 0.4, and high noise margin is the highest voltage that can have 2.4 minus 2.0, which will be 0.4 volts. So switching time and propagation delay time, when the from 0 to 1 or 1 to 0, how it will be taking, we can understand by this particular diagram. So the rise time is the length of the time it takes to for a pulse to rise from its 10% point to rise 90%. So this will be taking from 10% to 90%. How much time it is taking is TR, rise time, and fall time. Uh, the fall time is the length of the time is takes for a pulse to fall from its 90 points percent points to its 10%. Average delay time and high propagation delay time. So propagation delay time, TP is equal to TPLH plus TPH by 2. The propagation delay time is directly proportional to the switching time and increases as the fan out increases. So this is the how the propagation delay time for these ICs, estimated propagation delay time. Two modes of capacitive charging, discharging that contribute to propagation delay in the of the ICs that is manufactured using the MOSFETs. This is estimation propagation time. Then coming to this evaluation of TTL logic family. CTL family, the IC number starts with 74 series, standard TTL logic, saturated BJT, upsell. Now they are not in use, BJT technology, but whereas the next is the high speed TTL logic, decrease the resistance to lower the internal time constant but increases in P dissipation, and typical dissipation is 22 milliwatts and T is equal to nanoseconds. And TTL logic with L series, low power series, so increases the resistance to lower the power dissipation but increase the internal time constant, typical P 1 milliwatt. So coming to this, the dissipation time reducing, and the time taking is also will reduce. So which one is the best for designing the these ICs is the look into this. So short key TTL logic, deep saturation prevented by BC Schottky diode, reduced storage time delay, and practically obsolete. These are also not using, and low power Schottky, 2 milliwatts of dissipation, and time taken for this is 10 seconds, and TTL ALS, low power high speed Schottky TTL, logic innovations in IC design and fabrication, improvement in speed and power dissipation is popular. Now the transistor as a switch. So transistor as a switch, here again, not to discuss this here. The basic RTL is NOR gate. Input represents the logic level high and low, and low voltage drives the corresponding in resistance cutoff region, while logic level high drives it into saturation region. If both inputs are low, then both the transistors are cut off. They are turned off. So thus the voltage which appears output as high. So this works as input is low, then output goes output no, the transistor will be switched off, and when output is input is high, then output will be on and output will be 0. So which works as a inverter in this. Advantages of RTL gate. This is the DTL logic, diode transistor logic, also termed as DTL, replaced RTL family because of greater fan out capability and more noise margin. DTL circuits mainly consist of diodes and transistors that comprises DTL devices. The basic DTL device is a NAND gate. So two inputs in the gate are applied through diodes D1, D2. The diode will conduct only when the corresponding input is low. If any of the diode is conducting when at least one input is low, then output voltage, the output keeps transistor T in cutoff, and subsequently output of the transistor is high. If all inputs are high, all diodes are non-conducting, then diode transistor T is in saturation and its output is low. So this is the NAND gate made out of DTL logic. DTL, this transit, you have diodes, and you have a inverting circuit, that is saturation inverter. So these two inputs are given 0 0, then output goes high, then this will be conducting, then output will be 0. So both inputs are high, output will be 0. So this is how the diode transistor logic works. Then coming to the transistor logic, transistor TTL family is modification or to the DTL. It has come to existence so as to overcome the speed limitations of DTL family. The basic gates of the family is TTL NAND gate. Q3 is cut off when output Q4 is saturated and Q3 is saturated. When output Q4 is cut off, the transistor Q1 is on time. So this is what the diagram for this. So TTL diagram is already discussed. Now coming to the emitter coupled logic, ECL logic family implements the gates in different amplifier configurations in which transistors are never driven in the saturation region, thereby improving the speed of the circuit to a great extent. The ECL family is fastest of all logic families. So we prefer other logics compared to ECL logics. So the main advantage is the implements the gates differential amplifier is configuration. The transistors are never driven in the saturation region because they always the uh, properly biased circuits are existed here, so that always the transistor will be in the active region, so that the whatever the signal that will be sent at the given at the input, then immediately it will be transferred to the output, and then you'll get the output. The ECL family is fastest of all logic families, based on BJT, but removes problems of delay time by preventing the transistor from saturation. A very fast operation, propagation delays of 1 nanoseconds or less, low noise immunity of about 0.2 to 0.25, very less noise device it is. The input impedance is high and output impedance is low. As a result, the transistor change states quickly. The gate delays are low and the fan out capability is also very high. So always it is an advantage that input impedance must be high for any amplifier, so that output will be impedance will be low, so that it will be properly amplification takes place. And this logic we can make the manufacture the ICs. This is the differential amplifier configuration. We have two inputs, one here and another one is here, and this is another one. So basically there are three. Yeah, this is connected to the uh, 0.4 volts fixed voltage, and this is another input, two inputs here. So this is on in the differential configuration. So in this differential configuration you will be getting two outputs with respect to the ground, with respect to each other collector, the output will be taken across. And this is how the operational amplifier configuration also is made up of using this type of circuits only. So there also two inputs and one output will be there. So this is a unbalanced, this is a balanced output of the differential amplifier that we can get. So here function table, if you look at this logics, if you look at low means both the transistors are zero, so that output will be very high. So once it is output Vx, if you look at it will be 3.6 and 3.6 volts. The transistor Q1, Q2 are both are off because the input is low. The Q2, 1, Q2 transistors are also zero. Once in this particular case, what happens to the Q3? This Q3, the base is connected with the 4 volts. So always the uh, output will be given, so the transistor will be on state, so that Q3 will be on because this is sufficient base emitter voltage is supplied to the base of the Q3, then it will be on, then output voltage will be plus 5 volts that we can get. So from V out is 5 volts you get, and from VO 2 it will be around 4.2 volts that we get. So out one is uh, getting high, and out two is of opposite, that you'll get as zero. So where the symbol will have a bubble here, so negation of the two, so one is opposite to two. So similarly for L and H, both this Vx is high because this is 0. So and Vy is 4.4 volts. This input is high, so that output is connected with Vy. Y is high. Yeah, Y is high. Then output is directly connected to the output of this. So that output will be 4 volts you'll get. Similarly, this is 4.4 and 4.4 volts that you will get. So that the out one will be high, low, 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 that we can get it. This is how the ECL 2 input OR gate or NOR gate works. So this, if you put a bubble, then it will be taken as NOR gate, and then if there is no bubble, then it will be taken as OR gate. Now coming to the metal oxide semiconductors, considerably the low power, low energy consumption than the TTL and ECL, which has made portable electronics possible. Most widely used family for large scale devices combines high speed with low power consumption, usually operates from a single supply 5 to 15 volts, excellent noise immunity of about 30% of supply voltage, can be connected to a large number of gates, up to 50 we can connect. So this is a more versatile. This is a MOS, will be metal oxide semiconductor. There will be a layers will be there in construction of the MOS, so that it will be very much stable, and it's a voltage controlled device. So we making the ICs using this technology will have a great advantage. Then coming to the some statistical parameters, characteristics of the data logic families, basic gates, NAND, and NOR can be used as a OR or NOR, MOS as an AND, and CMOS, NOR and NAND gate that we can manage. Coming to the minimum fan out will be 8 to 10, and ECL logic will have 20 volt, 20 ICs we can consider. So they have a minimum is 24, whereas for MOS it will be 20, and for CMOS it will be greater than 50 fan out will be there. So the power dissipation is 8 to 12 milliwatts, and then the other will be, whereas coming to the compared to the TTL and ATL gates, ECL and MOS are having more advantages. And noise, coming to the noise, good, and this is excellent. Here ECL is compared to all, this is very good noise immunity, and CMOS is also having very good immune to this noise capability. Typical propagation delay is also very much uh, less, that is 70. It is good, and the ECL also will be, whereas the other are very much high, whereas ECL and CMOS are better in designing the ICs. Clock rate is also for CMOS is better compared to even for ECL circuits. So clock rate, minimum frequency at which the flip-flops operate. So minimum on and off should be very much fast, so that the data transfer can take place very easily, and we can use it. The number of functions, fairly high, medium, and very high, and all this high, and which is very low. So number of functions also similar is low, whereas for ECL it will be very much high.